They may avoid it. They may start to doubt themselves. Math anxiety as a result of these labels that we put on kids. And so we're giving students wrong messages when we start to label students as math capable or not math capable based on the kind of thinking that they do. So here's how we can redefine what it means to be good at math. First of all, let's understand the islands. So concrete island, this is where we're making sense through concrete thinking. We need objects. We're able to build things and see them and manipulate them. There's a lot of power in being able to make models and play around with these models to understand the math. Now, as we develop our thinking, one of the things that we can start to do is design representations of those concrete models, and we can make connections. So instead of building with base 10 blocks, we might draw a base 10 model. This is representational thinking. Now, when we go from one island to the next, we build a rickety bridge mentally that connects these ideas. And it's rickety in the beginning because it's new thinking. So as we start to think representationally, we can go back and connect that representation to our concrete models that we've been thinking about. And as we go back and forth across that bridge, we redesign the bridge. We build stronger supports and it becomes a much stronger bridge. So eventually, by connecting those two islands, we now have a really good, strong sense of this math idea through a concrete model and through a representation that we can make sense of. Likewise, when we do the same thing of thinking representationally or concretely and we move over to start to think about the math abstractly, we build another rickety bridge. So we might think about decomposing numbers and breaking it up, but it's really important for us to go back and consider how that looks in our representations or with our concrete objects. And as we go back and forth across that bridge, it gets stronger. We build stronger connections so that in the end, what we have by exploring math through these different ways of thinking is a good solid connection between all three islands. To me, this is what being good at math looks like. It means that we have the ability to think abstractly, but we can also make connections to representations and we can back up our thinking with a concrete model if we needed to. It's important to note two other things with this. First is that this is not linear. So you may have a student whose first way into the math is to think about it abstractly, but there's benefit in them going back and thinking about how their abstract thinking connects to visual representations or concrete models. Likewise, a lot of teachers may find also that they need to go back and revisit representational and concrete island. I know I did. I wasn't brought up that way in math. Everything was abstract to me. And so I found great benefit as an adult going back and trying to understand the math using visual representations and concrete models. What I like about this view of what it means to be good at math is that it's inclusive, right? So we have concrete thinking, representational thinking, abstract thinking. Every one of these islands, we're highlighting the thinking that's involved there. So we're not saying it's a high flyer who's on abstract island or a low kid who's thinking concretely. The idea is that no matter which island you're on, you're thinking. There's really strong reasoning and understanding at any one of these islands. And so being good at math means you have bridges that connect those islands. You understand fundamentally how the different ideas connect. And that's how we authentically include all students. So if you give a problem to the class and you have some kids who approach it abstractly and some are approaching it with a representation and some are doing a concrete model, what's great with that is as you come together to discuss these ideas, you can then have the kids build those connections. So as you ask someone, hey, can you show me where is the 64 in Julian's model? Or in Sarah's representation, can we see where that decomposing of the numbers happened? As we ask the kids to start building those connections, that's the bridge building. So what we're going to do now is define being good at math means having this flexible thinking with strong bridges that connect it. And being a good math teacher means you're a good bridge builder. You're helping kids to see the connections among all of these ideas. And hopefully when we do that, we start seeing a reduction in students who identify themselves as bad at math just because they haven't made it to a certain island within a given period of time. We want to value the thinking of all students, and when we do so, we authentically include all of our students in the math class and help everyone identify themselves as mathematically capable. So let's work together to redefine what it means to be good at math. Let's get rid of these labels of high flyers and low kids, and let's start thinking about how our students are approaching these ideas and supporting them at every stage of their journey so that people have good, positive mathematical experiences.
Okay, so hopefully you had time to listen and consider this idea of going in between concrete and representation and abstract models. And we're curious about what your thoughts on this video are, especially if you have a background in modeling instruction and how it resonates with you. So we would like you to open your mic to share your thoughts or drop your thoughts into chat. And while you're doing that, I'm going to stop screen sharing for a minute so we can see each other, hopefully, instead. It looks like Mary Jo already has a comment or a question. So Mary Jo, your hand's up. Would you like to comment?
I have taken, I'm an international teacher. This is the third country I've taught in. And I was fortunate enough to work with a woman that works for the Department of Overseas for American schools. And I took a course with her we started with kindergarten and worked all our way up to grade 8 and showed how we could use the manipulatives to model everything all the way up to the math in grade 8. And her statement that has stuck with me is read it, draw it, do it. And I that's something I talk to my students about a lot, is it's okay to draw it, be it a table or a picture like the 62 times 34 or whatever it was. You know, if draw whatever helps you to be able to visualize what's happening. And I do know that some students have found that useful, that they can make drawings. And I don't teach middle school at the moment. I teach grade 11 and 12, but I still say that to them, and they do find it useful.
Thank you, Mary Jo. I really appreciate that. And I have to say, having a history of teaching high school, I think in physics modeling instruction, we're constantly going from concrete to representational to more abstract all the time. And students will sometimes ask if they use something concrete or representational to solve a problem, if they've done it wrong, like using a graph to solve a kinematics problem instead of an equation. And then they'll say, did I do it wrong? And that's absolutely, we know that's not true, that you did it wrong. We're so glad that you can represent it in multiple ways. So I think this really speaks to that. Are there other, and I think that those kinds of models and representation need to continue to be used through high school, through college, because that's what we're constantly doing. Thank you so much, Mary Jo. Are there other comments? Does anyone want to put anything in the chat? Or Mike, Brenda, do you have a comment?
Well, I put half of it in the,
Please,
this
Brenda.
was my first response, because this is exactly as modelers, we know you got to put the three together. And for chemists, we also have the Johnstone's triangle that talks about the macro, the particle level, and the symbolic. And you can observe, you can draw, you can graph, you can do these things, or usually for us, it's draw a bunch of particle diagrams. But then the symbolic, all three of them have to get together. And yet this is what's valued so much in tests and, you know, blah, 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 online tutoring and all this, is that you can symbolically represent chemistry. But finding ways to represent the mathematics we use in these subjects so that it has concrete setting. You know, I'm going to be making a little presentation with some teachers in another week on representing reactions in a way that just is your understanding of reactions, that just is like tiptoe over and now do stoichiometry. And it's because you know, I've built representations that all tie together, that is that concrete representation, you know, experience with the lab, representing it in diagrams and groupings and blah, 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 and then get over the symbols. And then once you've done that, you can verbalize it. Stoichiometry is not that hard, especially if you prepared them with proportional reasoning. It's just not. And yet, to match the guy in the video, when I say, oh, I'm a chemist, I get, I hated chemistry, stoichiometry. You know, I'm no good at that. Or occasionally, oh, I like that. But mostly it was no. So yes, this is absolutely my experience that this is necessary.
Thank you so much, Brenda. And I noticed that Brian put in a nice comment in the chat about you could just replace every time the the presenter said math, you could replace it with science, and it would be similar. And I think the point that we kind of need to make with our middle school and high school teachers is that relying on the concrete thinking and the representational thinking is actually a strength, not a weakness, you know, and it's not just abstract thinking that gets you on the island of being a great achiever. So I think that is something that definitely can be emphasized with teachers. Are there any other comments that you want, that anybody wants to make on the video right now?
It just gave
Okay,
me
well,
some great
thank you. So
visuals.
now I'm going to try to give you yeah, I'm going to try to show you some more visuals that we've included in our resources for rational number operations and kind of give you an overview of what's available. Again, not necessarily as it's not necessarily recommended as a standalone unit, but just ideas for different representations and games. So I'm going to go ahead and share my screen again so that I can go back to my slideshow. So I hope you've had a time to review it. I don't know if there's any comments. If there are, open up your mic or drop something in chat. I like this because it shows all of these strands as being sort of interwoven. So it's not a matter of us jumping from one strand to the other in a linear progression. It's something that everything's kind of woven together, and that makes it a little more complex when we're thinking about teaching, but it really represents how students learn and think a lot better than trying to think of things as a linear progression. What this unit focuses on is actually just the 4 basic operations, and we start with a clear definition of thinking of these 4 operations really as not as an algorithmic thing, but as a verb of what you are doing. So when we're thinking about operation 1, which is addition, really what that means is to join as a verb. Subtraction really means to separate. Multiplication is to make copies of, and division is to separate into equal groups. So thinking of the things as verbs first, as opposed to memorization of an algorithmic operation, might help our students a lot, and being clear about what each of these operations actually means. So that's how the unit is split up into strategies for each of these operations. And to give you an idea of how we would start with some of these strategies, when we're starting with addition and thinking of it as to join, we start with an early activity that we were calling walking the number line, where we have a series of problems that could involve decimals, fractions, integers, a lot of different things. But what we ask students to do is represent them using a number line at first. So that's one of the early activities. And the hope is to have adding integers not just a set of procedural rules, but to develop a concept of actually doing an action, moving or joining, rather than just a set of procedural rules. So that's how we set up a conversation about addition. And then we go into giving some strategies for addition. And these strategies are actually included on an addition strategies sheet that we have here. And I might just drop that into chat so you can take a look at it. So let me do share. Of course, my computer's going very slow. It's thinking. Okay, so I'm going to copy the link and put it into chat for everybody so you can take a look at this, if I can find my chat box. Addition strategies. So I'll let you follow that link if you have it available. But I do like this. This is taken directly from the Fluency with Rational Number Operations book that we mentioned. And what's nice is that they do include diagrams of possible representations and ways of thinking with each of these ways to think of addition. And I think we often don't explicitly think of these different ways to do things when we're doing our initial instruction. And having different ways to think of addition and strategies to perform addition makes it more students stronger in doing that. So if it might be that some problems are better with this counting on way of thinking, and it might be easier sometimes to make group things into tens, or maybe it's easier to compensate, to think of a number that it's close to, and then try to take away that number, or to do parts of sums at a time. So these are 4 big strategies, but they also kind of come into play later on when you're talking about algebra or functions. We're kind of using these strategies in many cases implicitly, but at this point, we're talking about explicitly having different ways to do this that are accessible to students, and they practice the different methods. So this slide, going back to it, just has a summary of those addition strategies. The sheet that I shared with you is just much more robust. Counting on is a possible strategy, which is very commonly how we start with addition. Making tens makes things easier to add up. I know I often do that when I'm like playing Quiddler. I make all my cards into tens and then add them, group them into tens and then add the sums up. You can compensate by adjusting an expression to make it easier, and then compensate back to preserve equivalent. Or you can break things into partial sums, which is actually a technique for some calculus integration and things like that. So the idea here is to have students sort of think about these strategies and think about which strategy might be the best for depending upon what kind of problem you're trying to solve, so that it could make them more fluent. So that's kind of the addition strategies. There are some parallel subtraction strategies, if I can get my slideshow to go, which it's not wanting to do. So some subtraction strategies are very similar. I'm not going to necessarily give you the link to the subtraction strategies right now, but you can see them when I share the slideshow at the end. So instead of counting on, you can count back. You can think addition and find the difference. You can still do compensation, the compensation idea with subtraction, or the partial differences idea with subtraction. So they're very similar strategies. And what we've included in the unit are some ways to, oh, my screen slide oh, it froze again, but now it's good. So we included some sample games that you can practice these strategies with different contexts. So one of the game we included is called All Lined Up, and you can get 4 cards or you can roll dice. And the dice represents digits 1 to 9, and you can tell students to create 2 fractions and add them, or you could do decimals, or you could do whole numbers. And they're supposed to place a sum in the box of their choice on their sheet, and then repeat on the next round. And by the end, they're supposed to have the sums in order from left to right. And if they can't create a sum that's in order, then their turn is skipped. And then the first to fill all boxes is the winner of the game. And some comments about, and then another game that we're offering up is a Take 5 game, where each player takes 5 cards and uses as many as they can to get a sum that is close to a target number, and the target number is determined in advance. And you can make it a positive or negative number, you can make it a decimal, you can make it a fraction. And then if their sum is within 5 of the target, they get more points. If they use all the cards, make it. And the closest sum in any round scores bonus points, and the first player to get 40 points wins. So these are some possible games that you can do with either dice or with cards. Another strategy that we think it's really important for all of you to be aware of are these things called open middle problems involving addition. And we only have 20 minutes left of our webinar, so I'm not sure I'm going to have everybody share out their answers. But open middle is a really great resource, and we have these labeled as VW because we use them often as bell work. And the idea is you can print these on large cards if you want, or you can have the students recreate it on a whiteboard or something, but they're given digits that could be cards or little number tiles that have the digits 1 to 9, and they can use each of those tiles at once at most. And then they try to get as close as possible to creating an equation that is going to be true in these circumstances. And there is an entire movement called Open Middle that you can see their resources online, and they go all the way up to high school with algebra and functions here, as you can see. So that's another good strategy that you can use for trying to build some of this fluency. And then another thing that is a really good strategy that teachers can use is something called a number talk. This is a sample number talk involving addition, and there's some kind of rules about how teachers are supposed to implement number talks, and there's lots of resources online about number talks and how to use them. So the idea is that you put something, you post something probably at a slide where everybody can see, such as this one, this problem. And this problem might be good for several of the different strategies that I just listed, like 7.48 is close to 7.5, so you could maybe do some compensation. 8.9 is close to 9, you could do some compensation. But the idea is to have students think about this, and you should follow kind of a more a procedure similar to one I'm going to suggest on the next slide. So formal number talks, it's a huge kind of movement in mathematics education. What you do is you put all your books and writing utensils away. Students aren't supposed to be jotting things down. And what they do is they hold their hands near their chests. So not everybody in the class can see what they're saying. But when they're feeling like they have a solution to the problem, they're supposed to show their thumb. And so teachers can know who solved the problem and who hasn't. And then they can show additional fingers as they find more strategies. And then after they've had some time to think, they share strategies and you record them on the front board. With the talk focusing on explaining their strategies, and it's supposed to be a short in duration conversation. The middle school math team suggested some possible modifications to this for when you're doing high school. Maybe it doesn't always have to be mental math. So for example, we could use whiteboard markers to write things directly on a desktop or mini whiteboards. And then you also could use different problems that are pertinent to your students. And if a student makes an error, probably the teacher shouldn't be the one to correct it. Let the students articulate the error and make some changes. And then there's some links to resources about number talks also on this slide, so that when I share them at the end, you can take a look at some of them. I think I'll pause for a minute here and stop sharing. So those were just initial games and idea about addition and subtractions. And I wanted to pause to see, does anyone have questions yet or comments on any of this? Okay, so sounds like nothing yet. So I'll go ahead and go on to, oh, sorry.
That's
yes,
okay.
Brenda.
Yeah, the out of sync thing is sometimes I don't hear your question. Yeah, so it's okay. I just think I'm listening to this going, this is getting kids to talk. This is so important. It's getting kids to recognize there's more than one way to do it. It's getting kids to really see that there's so many ways. I mean, I know when I'm doing mental math, I usually jump between strategies. So, I start it one way, get it to a more familiar place, use another strategy, finish it up and self-correct. compensate. I do it all the time, but I do it fluently, but kids don't see that when I'm, thinking about anything. So, kudos. I think this is some really good stuff.
Yeah, and I think, thank you so much, Brenda. And I think all of us do all of these strategies all the time, but we haven't articulated in our own brains when we're fluent that we're jumping between these strategies. And so having some explicit ways to express it, even with our high school and college students, I think is really helpful.
I personally like that you are talking about lots of different strategies and students having different strategies. My experience with my own child has been, no, mom, that's not how you do it. The teacher wants it done this way. I don't know if that's a common issue, but I remember us getting in knockdown, drag out, discussions at the table at night.
Yeah, I did want to emphasize that these are now common practices that are kind of going across math education. So they are hopefully things that you can share. So it's become like that. I think we've all been there where our child tells us, well, the teacher had this one way to do it, and so that's the way we have to do it. And I don't think most teachers are saying that, but students often will default to that. So I'm going to go ahead into a little bit about multiplication and division, and then we'll have some closure. So I'll go back to share my screen. And again, apologies for the lag. My Zoom seems to constantly lag between my voice and my screen, and I'm sorry. Okay, so number talks, I said, are another great resource. So some strategies for multiplication, which is really to make copies of, are breaking things apart and making into partial products, breaking them apart by addends or breaking them apart by factors, and compensation, again, for multiplication. And I do have a multiplication strategy sheet that I'll go ahead and share as well with you. So you can take a look at these. So let me do, I just needed to do copy link and I didn't. Copy link, put it in chat. Multiplication. So I'll go ahead and put the link in chat so you can take the link and take a look. So I'm sharing my screen. Hopefully you can see while you're, maybe if you have the opportunity to surf to it. A lot of these strategies almost look sort of like an area model of multiplication, really. If you can see the break apart by addends, really, like the first thing when they're doing 26 plus times 47, they're breaking 26 up into 20 plus 6, and then 47 into 40 plus 7. And then each little rectangle can kind of be thought of as the area of a rectangle with those dimensions. So it's kind of like an area model in a way for a lot of these strategies. And there's also sort of some other strategies that, like breaking apart by factors, where you make things into factors and then maybe make it into an easier multiplication problem. And then also compensation, thinking of adjusting one of your factors, which is very similar to the compensation for subtraction and addition. So that's some strategy sheet for multiplications. And again, these are all going to be available to you by taking the links from the slideshow, which will be shared at the end. So I also wanted to let you know there is also some strategies for division, but that is what is still under construction from our group. We haven't had time, we didn't have time to kind of take a deep dive into the division strategies yet. So we don't have a division strategy sheet, but that will be coming soon, hopefully. So some possible games and activities that have to do with multiplication. we start with something sort of foundational, similar to what we did with addition, where we say solve the multiplication problems, but then we add the element of represent it with some kind of label diagram. So it could be, we give students the options to have different diagrams, but they're supposed to represent it somehow. So it can't just be hopefully an algorithm, they have some kind of diagram. We also have a true or false game. So you would kind of look at the statement and then decide, it kind of will list some kind of strategy, and then they decide, is it true or false that this is going to be the same thing, and how do you know? So explicitly diving into those strategies. Some possible games with these multiplication strategies. One of them is called Give Some, Get Some, and that has this sort of grid board of a bunch of different problems on a large grid with a game board. And there's several game boards available. Some of it will involve decimals, fractions, multiplication. And what they do is they take turns rolling some dice to create a number. You can decide how many digits you want the number to be, and how many digits of dice. I think we started with 2 die to make a 2-digit number. And then they're supposed to use some kind of compensation to make a whole, or you could use a different strategy and then solve the problem correctly using that strategy. And then you have to correctly solve it to claim the space. And the game ends when all spaces are covered, or the player with the most 3 in the rows is done, or you could play it like bingo, where they get some 5 in a row in any direction to win the game. So the game boards that are available look like this. And there's several that are available, and you can also create your own. And some comments on this, and playing games in general when you're in math class. A lot of us try to introduce the game by having the entire class play against the teacher for the first time. You can just leave it as a game, or you can try to get some accountability by having students record their work on the game board. But we did want to be cognizant that sometimes when you have too much accountability, it's no longer fun to play the game. So you kind of have to decide as a teacher when to do this and when not. And then some good times to play games are really usually near the end of the unit or quarter, or when the students seem overwhelmed and they need a break. So maybe it's game day for some of these different ideas. Another good game for multiplication strategies is this number hive game that's also freely available online. And here's some rules of the game. Basically, they have this big game board, and they start with a blank game board, and they have their own counters that are different colors. And you place 2 counters on each side, and then you place a third neutral counter on one of the number pads. And then you move the neutral counters to decide to create a new product or new sum. And then if they can make one that's going to create something on the game board, then they cover that that section with their colored counter. And what you're trying to do is get 4 in a row that go on the game board in order to win the game. So there's some number hive games online, and you could also do some of your own. We thought that it might be a good game to play with teams, like 2 people on each team. And then there's also a Math Olympiad protocol that might work. You have teams of 2 where teammates sit across from each other rather than diagonal, to promote some crosstalk about what they're thinking as they're playing the game. And then some other teachers had suggested some games called Happy Sad or Today's Date, where you try to create the date of today with some math strategies. Here's some sample open, middle, and number talks for multiplication that you could go through using the same protocols as we had mentioned on the other ones. And so that's kind of ideas on strategies for the multiplication. So as closure, I wanted to let you know what we've been talking about today is the modeling ratio and the fluency with rational number operations unit, which is the second one on this list. We also had 3 other units that we were emphasizing in our middle school math curricular materials. We have modeling ratio and proportion, and also linear relations relating to functions and making sense of data. And then I wanted to make a couple of announcements about this summer while I have people here. We just decided that we have some funding to offer some math underpinnings workshops with STEM Teachers Phoenix this summer. And so we decided we're going to host these in Arizona on the Arizona State University Tempe campus, concurrently with other modeling workshops that are taking place on the campus. You can see those events that are going to take place on campus on the AMTA site. So what we're going to do for our math events is in June 17th through 20, we're going to do a bridging math and science with proportional reasoning unit. And then I want to note that right after that is the AMTA conference at Arizona State University. And then the week after that, we're going to do modeling functions and linear relations for interdisciplinary fluency. And that is going to be also on ASU campus. And also really quickly after that, there is a Building Thinking Classrooms conference, and Building Thinking Classrooms is very aligned to modeling instruction, but it's mostly used in mathematics right now. That's happening at the Arizona Biltmore and might be of interest to some of our members. So I'm going to stop sharing just for a minute and see if there's comments or questions on this right now.
Kelli, I have a question about the workshops and what you just showed. Is that something that occurs every summer? Okay, and
No,
in Arizona?
But okay, so the regular modeling workshops, chemistry and physics, do occur every summer in Arizona. And I'm affiliated with Arizona State University, so I work for the physics department there. So we have a Master's of Natural Science program, and to get that, it's geared towards teachers. People to get that master's have to take at least 3 modeling workshops. So we've always offered the physics and chemistry modeling workshops, and it's been geared towards sort of high school and community college teachers. But I want everyone on this call to know that new to the ASU physics department, we are considering remodeling that Master's of Natural Science to be more inclusive of like sort of the physical sciences and the middle school sciences. And we are thinking that maybe adding these math workshops will be a possibility in the future, but this will kind of be a pilot because we have funding this summer. So we're going to do a pilot, and what we're hoping, we're inviting modelers of all walks of life. If you're going to be in town for the AMTA conference anyway, if you want to come early or leave late, we're going to hold this math thing on campus near everything else, because we would love to have people across discipline join one or the other or both of these.
Thank you.
Other questions that I can answer? Yeah. Okay, I am going to put a link to the slides in the chat right now. I'll do it while I'm sharing my screen so you know that there's other options here. So I put links to the other resources on some slides that have a blue background near the end of our slideshow, just so you know. So they're on there on this slideshow. So if you want to see any of our other resources, and these first two, the rational number operations link, that's the ones I shared today. And then the modeling functions leading to linear equations, that's going to be in our second week summer that we're focusing on that stuff, but we're going to make it interdisciplinary for all STEM. And then this is going to be the first week this summer, the modeling ratio and proportion. And Brenda and the chemistry folks have a lot of things that are similar to that. So we're hoping to get some cross-pollination, I know, with them. And then this is the link to today's slide. So I'll go ahead and copy so you guys can put it into chat. Today's slides. And I'm sure that Sue will share all this out too. And then there's also a link to today's materials and past agendas for our workshops in case you're curious about how they went. The ones we're going to do this summer, this is on the last slide, they're very similar to these agendas from last summer. Just so you know that they're available. So I am going to stop share now. And I know that Sue also has a link to get a certificate for today's PD. So Sue, can you put that link in the chat if you did not already, or maybe put it in again?
Yep, I put it in the chat right above yours. I will place it in there again. If anyone should need a certificate of attendance for PD purposes, all you have to do is complete the form here, and we'll email you a certificate within the next 2 days. Kelly, thank you so much.
Yeah, and
learned so much from every one of your math webinars. I can't tell you how much I've learned from all of this. So thank you.
Thank you so much, Sue. And I want to mention that the 2 math workshops we're offering this summer, registration will be through STEM Teachers Phoenix, which is affiliated with AMTA. We have not updated the language on those yet. So we just found out that we're going to be at ASU, and we just decided what's going to be the focus of week 1 and week 2. So right now, if you go to register, it just says week 1 math, week 2 math. We haven't put the official titles. We will be updating that registration, and then I'll ask AMTA to send out a blast of, you can also sign up for these when they're ready. It will be sometime this week. But we would love to see any of you. I know it's hot in Arizona, but that makes it so that it's cheap to visit. So I hope to see some of you there. And I want to honor your time. I know it's about time to log off. So thanks, everyone. Feel free to go when you're ready, and I'll stick on for a couple minutes in case you have questions or comments.
Thank you, Kelly.
Thank you. Thanks, everyone, for joining.
Thank you very much.
Yes. I know you put it in I put it in the chat, but you and Mitch and I need to get together at some point, because he'll be doing the chem. I'll be there for the leadership. I wish I could stop in and see your workshop, but, and then we'll have the conference. And are you guys doing any presentation at the conference itself? You are, aren't you?
We are, but yeah, we're probably just going to give a real brief overview of what the units are about, because there's not much time to do much else.
Oh, no, I know. I'm giving a real brief overview of how we've changed chemistry too. Those might be simultaneously.
Yeah, I think we're going to try to not do the proportional reasoning with chemistry at the same time as we talk about middle school math. We're trying to coordinate that.
We try to make them at different times. Yeah,
so Brenda, you'll be on. Okay.
Yep. Colleen and I are doing the leadership workshop.
Brenda, you'll be on campus for. Okay. All right, so that sounds good. Maybe you can drop by sometime. We can at least talk to each other during lunches and breaks.
Yes, and then that Saturday, when we're doing our proportional reasoning thing, I suppose you guys will probably be there. Yeah, so that you can come. That will give us some cross.
I don't know.
Yeah, that'll give some crosstalk time. That's good. And any other time we might find over lunch.
This will work out well.
Yeah, I'm really happy. This is good. So, and then I have to jet Saturday night because I have to go home and get ready to drive to Cal Poly to do the Chem 1 workshop.
Oh, okay. Yeah, I know the AAPT summer conference is like the week after everything too, so I'll have to be going to that. But yeah,
Yeah.
very
Oh,
similar.
it's feeling more like that things that I've been thinking about in my little world are becoming more common conversation. They have been becoming more common conversation. And that there's probably some really good foundations for getting some voices going in the same direction. It would be a delightful thing to do some things where we might like work on ways to train science and math teachers about that cross connection between those two subjects. You know, I happen to use a lot of similar language about the 4 basic operations, just reminding kids it's not a button on your calculator. You know, it has a meaning when we use this. There is one other piece that division sign can mean when you're working with quantities, and that is relational connection. So you have proportional change that's not dividing into groups because you can't regroup one by the other. So like, you know, this velocity or density or molar mass or
Yeah,
something like
agreed.
that.
And I think we're trying to capture some of that in our proportional.
Yeah.
We try to capture some of that in our units. It's telling me my internet connection is unstable. So I'm probably lagging even worse.
Yeah, it's a little in and out, but that's okay. Anyway, thank you so much. I've enjoyed all of what you guys have presented.
I don't know if, does Colleen have one coming on up on making sense of data, Sue?
Sorry, my dog was going crazy. Colleen has Making Sense of Data Part 2 tomorrow night.
So
okay, well, I think it's about time to head out.
Yep. Thanks.
yep.
Thank you so much
Anyway,
for attending.
Yeah, and thank you, Kelly and Sue, for making this possible.
It's all Kelly.
We'll see you in June, if not before. Okay.
Thanks, everybody.
Bye-bye.
Definitely. Yes. Bye-bye.